Stanford University.
Okay, well, welcome to Lecture 9 of Stanford CS 193P, fall of 2017. So we have two major topics today. We're going to talk about the view controller lifecycle, which is when your MVC comes alive and does all the things it's going to do, and then dies eventually. And then we're also going to talk about a UI view called scroll view, which allows you to look at large UI views by panning around on them, zooming in on them, etc. All right, view controller lifecycle. So the view controllers have a lifecycle. It's essentially marked by sequences of messages, methods that are invoked on the UI view controller. Why do we care about this at all? Because at the various stages of the lifecycle of the view controller, we might want to get involved, right, and do certain things. So this lifecycle starts with the creation of your UI view controller. For your view controllers that you write, this is almost always coming out of a storyboard, right? You drag something in a storyboard, you put your views in there, that's how you know how to create an MVC. So your life cycle is going to be when your app runs and you segue to something, or it's your first view controller in your storyboard or whatever. Now iOS also has some API, which we haven't learned about yet, that can hand you a view controller, okay, that you can then segue to or whatever. For example, there's a view controller that lets you take a picture with the camera. Okay, so it can come from code as well. It's not only out of the storyboard. But once it's created, what happens to it? And you've already actually learned a lot about the life cycle of a view controller. Of course, the first thing that happens after it's created is that it gets prepared to be segued to, right? So if it's being put on screen because of a segue, the preparation part happens. Then, after that, importantly, the outlets get set. Okay, all your UI buttons and whatever, those connections get made. Then your view controller appears and possibly disappears on screen, right? Imagine a split view in portrait mode, right? The master disappears and you can slide it out and then slide it away. So it's appearing and disappearing, for example. Also along the way, as all this is happening, you might have geometry changes. Most notably, you rotate your device and you go from having this tall, thin rectangle to a shorter, wider rectangle, okay? So geometry changes can happen. They can happen for other reasons as well. Again, in a split view, you know, your master, sometimes it's in the little tall thing on the left, sometimes it's in a shorter thing on the left, and the thing on the right is sometimes fills the whole screen, or when it's in landscape, it fills just a part of the screen. So the geometry is changing depending on the situation of your view controller. And then lastly, and by far least importantly, in low memory situations, you might have your view controller asked to free up some memory. We'll talk about that in a second. All right, so let's talk about all the methods that get sent to your view controller when all these things happen. Now, you already know the first one, view did load. I mentioned it in your homework. It's a really powerful place to do initialization because you're already prepared and all your outlets are set. So now you really can go to town. And so it's great for that, and we usually put most of our initialization in view did load, with one huge exception, okay, and it's in red, so don't miss it, geometry, okay? When view did load runs, your bounds have not been set yet. So do not put things in here that have to do with the size you are on screen, because you have not been fitted to whatever device you're on. Okay, it's very important. It's a very common mistake to put stuff in here and then you just wonder why when you run it on a different device, your code doesn't work anymore, okay? So do not put geometry. I'm going to show you where to put your geometry changes in a moment here, okay? So that's view did load, a great one. The next one is view will appear, okay? Now, by the way, notice in all of these, I'm calling super view will appear or super view did load in all of them. You always do that. Do not forget to do that. In fact, in a demo the other day, I noticed I forgot to do it, and so we'll fix that in today's demo. But, and I've noticed in your homework, many of you did not call super view did load. Now, of course, we didn't talk about view controller lifecycle, so I don't blame you for that. But from now on, don't forget to do super. Give your super class a chance to find out it's appearing or that it got loaded or whatever. So view will appear. What do you do in view will appear? View will appear is exactly what it sounds like. Your view controller's view is about to appear on screen. So this is where you can catch up with stuff that might have gone on in the world while you were not on screen. Okay? Or if this is the first time you're coming on screen, catch up with the state of the world. So this is really a place to kind of load up your view with all the information from your model, especially if your model can change. Like let's say your model is a network database, okay? Other people are editing it, so it can change. So here's where you'd want to get up to date. Because when your view is not on screen, you don't want your view controller to be doing much work. okay? It just wants to kind of sit there quietly, and then when it's time to come back, then it does its little setup in here. One thing to notice about view will appear, of course, it can be called repeatedly because your view controller can go away and come back and go away and come back. But view did load is only ever called once in the lifetime of your view controller. Okay? It's just called once after you're prepared and your outlets are set up. It gets called once and that's it. But view will appear obviously can be called every time you're going to come back on screen. Now there's also a view did appear. Okay? This is called to you after you have come on screen. Now, what would you want to do here? It's a little late to do things like update your view from your model here because things are on screen. You don't want things to come on screen wrong and then view did appear and now you've cleaned them up. But this is a great place to do things like start an animation, because you can't do that in view will appear. You're not on screen yet, right? Start a timer that does something on screen. Start observing something in the world, like GPS locations or maybe the gyro position of your phone. Okay, those are all the things you can do once you're on screen. Okay, so that's what view did appear is really good for. One other thing you can do in view did appear is maybe kick off a very expensive thing. Okay, something you don't want to kick off in view did load because when view did load happens, your view controller may not actually appear on screen. Okay, there's no guarantee that anyone's ever going to actually put you on screen. So view did load is not a great, even view will appear, surprisingly, might get called on you and then you don't actually appear on screen. So view did appear, you know you're on screen, so it's worth it to do something expensive. Now, what would be something expensive? Oh, let's say you want to fetch a huge image off the network. Okay, almost any time you're going to do something on the network, it's pretty expensive. Because on a phone, maybe you only have a cellular connection, it's a bad connection, you're out in the country road somewhere, it's barely getting any, so it could be really quite expensive. For the same reason, these expensive things, we almost always do them in the background. Okay, and on Wednesday, I'm going to talk all about how to put things in the background. That's because it is absolutely primary goal, primary thing you must do with any iOS app is you never block the user interface experience. Users always have to be able to touch on things, swipe things around. If they swipe or touch and your app is frozen, they will not use your app, believe me. Okay, so that is of primary importance. And the way we do that is by putting things that would block, like waiting for something on the network, off the main queue, we call it, off the main thread, into these background processes. So we'll talk all about that on Wednesday. But view did appear is a great place to kick those things off, okay? Because you don't want to waste their cellular data usage fetching an image if you're not actually going to appear. Now, what this means, though, is since you're kicking this off in the background, when you've already appeared on screen, you have to design your UIs so that they always work, even if the expensive thing is not come back yet. Do you see why that is? That expensive thing might take 10 minutes or might never come back because of bad network, for example. So you have to put placeholders or spinning wheels or loading ... or some animation that shows the user, yeah, I'm fetching your thing, I'm working on it. But your UI still has to be fully responsive. If they're in a navigation control, they have to be able to hit back and give up, okay? Or they have to hit a tab at the bottom and go to a different tab or whatever they want to do, okay? So designing UIs that are like that take a little bit of adjustment. So far you haven't had to do that probably, so you're mostly thinking linearly. Okay, I am going to put this image on screen, so I will go get the image, then I will put it on screen. Well, you can't think like that. You have to think, I want to put this on screen, so I will put an image displaying thing on screen that is not loaded with a little spinner, and then later, and the user can do whatever they want, and then later when the picture arrives, now I will update my UI to show that image. Okay, so it's a little bit kind of thinking with another dimension, the dimension of time. Okay. All right, so there's also view will disappear. You get this right before you go away. This is a great place to undo what you did in view did appear. Okay, so if you started a timer or started some animation or started watching GPS or something like that, this is a good place to stop doing that. Okay, because you now know that you're going to disappear. Okay, and then when you reappear, you'll turn it back on in view did appear. So they kind of work together, these two. And then there's view did disappear. Okay, this one gets into you after you've completely disappeared. Usually we don't do much here, but you could imagine maybe cleaning up your MVC here, possibly saving some state or something, but this one is rarely used. Okay. All right. I've said that in view did load you cannot do geometry. So where do you do geometry? Well, you might think, oh, I can do it in view will appear, because I'm just about to appear, and so my geometry will be right. No. Okay, you would think that, but that'd be wrong. You obviously can't do it in view did appear, because now you're already on screen. It's too late, okay, to do anything about geometry. So the place you do geometry is in these two methods, view will layout subviews and view did layout subviews. These two methods are sent to your controller when its view, you know, the self.view, right, the top level view of the controller, that var view, when that view, just before and just after, that view is sent layout subviews. Okay, so why would that top level view be sent layout subviews? Same reason any other view. Maybe subviews came and went out of it, that's a common one, or its bounds changed. So this is why this is a good place to put geometry changes. Okay, because this is always going to happen when the bounds of your top level view change. Now, usually you don't need to implement these methods. Why? Because you use an auto layout, right? All that control dragging, pinning things to the edges, keeping things in the center, fixing aspect ratios, all that business. You're doing that. And that is automatically being evoked in the layout subviews of your top level view. So you don't actually need to do anything in your controller. Okay? But if you do feel like you need to do something in your controller, this is definitely the place to do it. Now, one thing about these two methods you have to be aware of, they could be called quite often. Okay? And at times you might be surprised, like, whoa, nothing changed. The bounds didn't change, nothing changed with the subviews. Why did this get called? Well, the system is allowed to lay out the subviews, ensure the layout of the subviews of any view at any time. Maybe it wants to do an animation and it's laying out the beginning and end stage that it's going to do a flip between or something. Okay, and the bounds have not changed, but it wants to make sure the views are laid out, or it's laying them out in the destination, you know, the end of the animation, etc. So it doesn't really matter why, but the system is allowed to call it anytime it wants, and so since it can call layout subviews anytime, these could also be called anytime. So you want to make sure these, if you do something as a reaction to your bounds changing, you want to make sure these methods properly and efficiently work, even if they're repeatedly called. They might be called twice in a row with the exact same bounds, for example. So you wouldn't want to, if you had to do something very complicated and expensive, you certainly wouldn't want to do it twice, okay, in a row. Okay, so that's geometry. Now there's a special case of your geometry changing, which is auto rotation. So this is you turn your device from landscape to portrait or back and forth. And when this happens, of course, you get that layout subviews thing because your view's bounds change, and so you get view layout subviews, but you also have this animation that's free going on. So iOS automatically animates the moving of all your subviews from the portrait layout subviews to the landscape layout subviews positions. It does that for you. Now, that's great. That saves you a lot of work. But if for some reason you want to participate in that animation. Now, why would that be? I don't know if have you guys ever looked at the calculator app on the iPhone? When it's in portrait, the buttons are really big, and there's not very many calculation buttons like times, plus, minus, equals. That's about it, right? But when you switch to landscape, now the buttons get small, and there's a whole bunch, square root, logarithms, all kinds of other things. Okay, well, when this rotation happens, the calculator app wants to get involved because it wants to animate those extra buttons appearing on screen, maybe. Okay, also the layout changes from being kind of big buttons in the middle to those buttons being on the side and new buttons appearing. So that's where you might want to participate. So how do you use this method, view will transition to size with coordinator? To do that, well, the coordinator that's passed to you is the animation coordinator. It has a method in it called animate alongside transition. And in there you can provide it a block, an animation block, right, a closure, and do your animation, and that animation will be performed alongside the animation that the system does when it rotates. Okay? Now I'm not going to talk any more about it than that. It's just so you know it's there. 90% of the time you don't need to do that. Now in your current assignment, assignment 3 or assignment 4, you probably, if you're far along on it, or if you're not, you'll notice eventually that you've got animation like cards being dealt out. Well, what happens if you start dealing out a card, it starts flying across the screen, and then you rotate? Okay, rotate your device. Well, what's going to happen is this is going to try and do some animation. Now, I specifically put in the assignment, don't worry about that. Okay, you don't have to worry about that case this week. But you might ask, well, what do I do there? Okay? Well, you have to understand that that might happen and deal with it, because when you're throwing a card out across the screen there, and this thing starts to animate that same properties of that same view, it's going to put it possibly in the wrong place, okay? Because it's going to move it to a new place. It probably does animation begin from current state. And so you could end up with views totally in the wrong place, okay? So you need to be able to set up your animations so that if they get taken over by someone else, all right, that they end up in the right place at the end. Okay, and so that can require a little bit of tuning. Like I said, this animation tuning business, that might require some of that. But not required for assignment 4. It's a little bit of advanced animation to have to deal with that. All right, this last one, and definitely the least, is low memory. This would only be, you would have only any interest in this if your app had large memory items like videos, images, huge sound files, okay, very high resolution, big sound files, for example. And, you know, it is possible that an iOS device that had many apps that were doing a lot of big photo manipulation or something, that it could possibly run low on memory. Most new ones have so much memory, this doesn't ever happen. But maybe if you had an app that had a memory leak, that was leaking big images in memory, then it could happen. But anyway, you'll be sent this when that happens, and all this is asking your view controller here is, please release anything from the heap that you can recreate fairly easily later, okay, or when you need it. And so it's kind of a memory cleanup kind of thing. One thing I will say is, if your app is leaking in the heap, and you are getting larger and larger and larger, and it sends this to you, and you have bad code, and you don't know how to clean it up, and you continue to leak, iOS can kill you, okay? So if you are a big memory hog and you keep leaking, you can be killed. So it's kind of the dangers of being a bad programmer, I guess. Drive and get killed. Almost never happens, though. All right. The last thing is actually back to the beginning, which is waking up from a storyboard. This is not strictly part of the view controller lifecycle, but I put it in here because any object that comes out of a storyboard, all your UI views and your view controller, gets sent awake from nib, okay? This is sent very early, right after initialization, before preparation, before your outlets are set, okay? I tend to stay away from trying to use this unless I really do need something set early. Now, we used this in the demo the other day because I wanted my master of my split view to be the delegate of the split view really early, before the split view started collapsing things on top of other things. I wanted to get myself in there as the delegate. But normally you don't put things in awake from nib, and I would say try to put it in one of the other ones first, and if you really need it this early, then you can go and do it in awake from nib. Of course, this is only going to work for MVCs that come out of storyboards, but again, that's almost always yours. Your ones always come out of storyboards. It's only the system ones, like the camera one, that you get from code. Okay, so here's a summary of the view controller lifecycle. You're instantiated, usually from a storyboard, but sometimes you can ask iOS for a view controller. Then you get awake from nib if you're coming out of a storyboard. Then segue preparation happens. Okay, some other MVC prepares you. Note that your outlets are not set yet. Then your outlets get set. Okay, get wired up by iOS. Then view did load gets called. All right. Then you appear and disappear off screen, and you get those view will and did appear and disappear, okay, back and forth. At any point along here, your geometry might change, causing view will layout subviews and view did layout subviews to get called, probably with auto layout happening in between those two calls, because layout subviews will cause auto layout to happen. And if at any time you start using a lot of memory, or even just the whole device uses a lot of memory, you might get this did receive memory warning, which you can hopefully clean up something too, but often you can't because you just don't have anything big. All right, so that is the view controller lifecycle. Now I have a little demo here. I'm not going to spend too much time on this demo because we got scroll view to demo here, but what I'm going to do is show you a little piece of code that you can drop into your apps, okay, it's a subclass of UI view controller, and you can just change all of your view controllers to inherit from this instead of UI view controller, and it will essentially just put a print statement of all of the view controller lifecycle methods. So you can look in your console and see what's happening in the view controller lifecycle. I'm going to do it a little bit today just to show you kind of a couple of interesting things about that. So I'm going to do this to concentration. Okay, here's our concentration. Oh, yeah, by the way, this is where we left off last time. Here's awake from nib. Oops, super awake from nib, okay? Awake from nib you also want to call super, even though, again, it's not strictly a view controller lifecycle method. You still want to give your superclass a chance to do it. So how does this code that I wrote work? Okay, well, here it is right here. Where is it? Somewhere over here. I'll get these things out of the way. There it is. Okay, here it is right here. Let's drag it in and take a look at it. I'm going to copy it in. All right. So what does this thing look like? It's exactly what you would think. It's a subclass of UI view controller, and it just has prints for all view did load, view will appear, did receive memory warning, layout subviews, will transition even. It just prints them out on the screen when it happens. It also has kind of a cool little var, this thing, VCL logging name. When it logs it on the console, it will use this string to identify your view controller, or if you don't subclass this, it will just use the name of the class. This is, by the way, how you get a string, which is the name of the structure class you are in. Okay, string describing type of self. That's how you do that. So I'm going to make my two view controllers in concentration, right? I've got the theme one and the game one. So here's the game one. Instead of having it inherit from UI view controller, I'm going to have it inherit from VCL logging view controller. So now it inherits the ability to print out all those view controller lifecycle methods. And I'm going to override this, what did I call it, VCL logging name. And I'm going to return game, just because it'll make our console output a little clearer which view controllers are which when it's logging. Okay, so it's going to be called game instead of calling it concentration view control, which is kind of long and very similar to concentration theme chooser or whatever it is, view controller. And I'm going to do the same thing with my theme view controller here. I'm going to have it inherit from VCL logging view controller, and I'm going to change its name, VCL logging name, to be theme chooser. Okay? So that's all you need to do. In fact, you don't even need to do this part. If you just make your view controller inherit from VCL logging view controller, it will log. So let's go ahead and run. Let's run this on iPad, see what happens. Let's go bring our console up here so we can see what's going on. All right. So here is our concentration game showing up in landscape. And you can see right away, look at this, init from coder. This init from coder is when something comes out of a storyboard. So both of these are initialized, both of them awake from nib, you see. Both of them have their outlets and everything set, and then view did load happens on both of them. They both are told that they will appear. They get their subviews laid out a few times. Look at this, view will lay out subviews. This one gets laid out twice, even though the bounds have not changed. Then the theme chooser gets a view did appear, and the game gets a view did appear, and they appear on screen. Now what happens if I rotate this to portrait? Okay, now when I go to portrait, I get theme chooser, the master, will disappear because it disappeared, right? It's no longer here, no longer showing. And I also get this whole transition to with coordinator because it was a auto rotation, so we have an opportunity to participate in the animation if we want. The game, of course, got a new size. See, it's now 7668 by 1024, so it got layout subview sent to it. And then the theme chooser also got its size laid out for some reason, and then it disappeared. Now if I drag it out, let's see what happens. Now I get the subviews laid out, and view will appear and view did appear for the theme chooser. You see what's going on here? So as this is happening, it's telling us exactly what's going on. Now I'm going to show you one other thing about this, which is kind of interesting. Let's go to our concentration theme chooser. Oh, we were already there. Theme chooser view controller. I'm going to make it, we put a lot of code in here so that it wouldn't segue if it could. So I'm going to make it so it always segues just by commenting this out. So by doing that, I've made it so that every time we choose a game theme, it always segues. And I do that because I want to show you, let's even go over and do this on iPhone just to see what's going on there. Show you what happens in the view controller lifecycle when you are segueing, because it's important to understand that. Okay, so let's bring this up, and then, sorry, see this happen here from the start. Okay, so this is a very interesting start right here, because we see that we created them, we wake from nib, we loaded them, we got the game, view will appear, but it never did appear, did it? Right? Because we did that thing where we stopped the collapse, remember stopping the collapse in the split view controller? It never appeared. So it got view will appear, but never view did appear, because it didn't actually appear. So there's another reason we want to wait till view did appear sometimes to kick off something expensive. All right, and they both got laid out and the chooser did appear. Now when I click on one, okay, here it creates a new game MVC. You see that? It's new. This 2 means it's a new instance. This is the instance number of it. And notice, look what happened to the first one, the one that never appeared. It left the heap. And that's what happens when you segue. You get a new one and the old one leaves the heap. So the new one gets view did load, view will appear, view did appear. If I go back, okay, I get some view did appear and disappear because this one appeared and the other one disappeared. And then if I segue again, now I get a third MVC and the second one leaves the heap. So this is what I was saying about when you do segues, a new one is always created and the old one gets thrown out of the navigation controller and leaves the heap. Everybody got that? Okay, that's all I wanted to show you. This is more just code that you can use to kind of figure out what's going on in your own app if things are not working the way you expect. Okay, let's head back over here, continue our slides and talk about scroll view. Okay, so scroll view, you know what a scroll view is, right? You have a little area on screen and you want to look at something big, so you got a scroll view. You can scroll around it with your finger and pinch in and out to zoom in on it. I just want to make sure you understand that scroll view is a very powerful UI view, okay? And it works really like a UI view in pretty much all circumstances. Here's my favorite little demo, a little, what do you call it, recording to show in this class, because this, I believe, is an iPhone 1 that you're seeing up here. But even back from the iPhone 1, scroll view did this. Now watch what happens here when I start this thing going. You can see that I've got a scroll view, a horizontal one that I can scroll between, and inside it are vertical ones. Okay, so it is perfectly fine to have scroll views inside scroll views. Here's another one, okay, where we're scrolling horizontally between these stock quote views or whatever, and then when we get there, we can scroll up and down. Okay, so scroll view knows how to live within itself. It knows how to live in virtually every environment. Scroll view is really amazing little class. So let's talk about how scroll view works. It's actually very simple to use as well. You already know how to add subviews to a regular UI view. So I have a regular UI view here. I just create a view, set its frame, and add it as a subview. It appears, right? Surely with assignment 3, you are intimately familiar with doing this. So how does it differ if it's a scroll view? Okay, well in a scroll view, there's one kind of huge difference, which is that we create what's called a content size. When we specify this content size, we're specifying the size of the area that the scroll view is going to scroll around. Okay, so this is the big thing that the scroll view, which is little, is going to look around in. And it's only a size. Its origin is always 0, 0, this little content area right here, so we always just specify the size. So this var, content size, that you see right there in scroll view is crucial. It's the most important var, maybe on any class anywhere. Okay, it's the thing that tells the scroll view how big the space is. But after that, adding subviews looks just like another view. Now I can create a frame, add a subview to the scroll view, and instead of putting it in the black square over there on the left, it puts it in that content area instead. Okay, same frame, but it puts it, still uses the frame to place it, but it's doing it in the content area. And I can put other things in there, multiple subviews, as many as I want, so here's 2 of them. And now the scroll view, what it does, it just lets you have a little window that is scrolling around as the user pans around here, and of course they can zoom as well. Now you can reposition the subviews in that content area just like you can in a regular view subview, right? So I just new frame, set that thing to have a new frame, it repositions, set the logo to have a different frame, it repositions. Now I have all this white space on the edges, I don't want it anymore, so I can just reset my content size to fit the aerial frame, right? And now when I scroll around, I'm just looking in this new content area. Got it? So that's it. So just that content size is the key. Now, because of this magic, there's a couple other interesting things about scroll view, like it has a var called content offset. Content offset is just the X and Y position of the upper left corner of what the scroll view is currently showing in that content area's coordinate system. Okay? So it's just kind of exactly what it sounds like, the offset of the content that is being shown right there. And you might be zoomed though, okay? And if you're zoomed, you're probably much more interested in what is the rectangle in the content area coordinate system that I'm looking at. Because maybe I'm zoomed way in on one of the windows there in the quad, and I want to know that window. Well, that's going to be a very small rectangle, that window, because I'm zoomed way in on it. And the way we do that is using the same methods that you probably use or you might have used in your assignment, which is UI views methods, convert from and convert to points and rectangles. Those all work in UI scroll view. So if you say convert from the scroll view to this aerial views, you will get the bounds of the scroll view in that view's coordinate system. So that's how you can find out that rect in the aerial views coordinate system, okay? Just normal convert, nothing special there. Okay, so how do you create a scroll view? Well, you can drag one out, of course, out of the little object palette. You can also select a view in your storyboard and go to the embed menu, the same place you say embed in navigation controller, and say embed in scroll view, and it'll wrap a scroll view around. Unfortunately, it puts about a 20-point border around it, which I don't really like, but it does. I'll show you that in the demo today and how we get rid of that. So you can kind of do that either way, or you can obviously create them in code, right? It's just a UI view, so it has the init with frame initializer, so you can do that as well. So once you've created your scroll view or put it in your storyboard and created an outlet to it, then you just say add subview to add your subviews to it. But this will do nothing, okay? Nothing will appear on screen until you set your content size. Okay? If you don't set that content size, then the scroll view will be scrolling over a little 0 width, 0 height rectangle in the corner. And if you put a subview in there, it probably will spill over and show, but there'll be no scrolling. So if you use a scroll view and your image appears or your views appear, but then you can't pan or pinch, it's probably because your content size is 0. The panning and pinching is only happening in the content area. All right? You can scroll programmatically. Of course, the user can scroll with their finger, but you can do it in code by saying scroll rect to visible. You just specify a rectangle in the content area, and it will slide over to show that rectangle. You can control a lot of other things that I don't have time to cover in scroll view. For example, when a scroll view first appears on screen, it can flash its scroll indicators. Okay, the two things that kind of show you where you're scrolled on the edges, they can flash. That's the default, in fact. But there's this var flash scroll indicator. You can turn it to false if you don't want it to do that, etc. Also, scroll view is super smart about safe areas. Okay, remember we talked about safe areas like the place at the top of the iPhone 10, or you're in a navigation controller in the title, or a tab bar at the bottom where it's like not safe to draw there. Well, scroll view, even if you make the scroll view underneath those safe areas, it will let you scroll your content into the safe areas, but if you scroll all the way down or all the way over, then it'll make sure your content is not obscured by the safe area. You'll see this in the demo, okay? So scroll view really super smart about safe areas. Because it is often the case that when we have a scroll view, we might want to go full screen to get as much of our image on screen as we can. But, if we've got some pixels in the upper left corner, we don't want them to be, underneath the little black bar at the top of the iPhone 10. So we want to be able to make sure we scroll down there that far. Okay? Now, what about zooming? So far, we've only talked about panning, moving the scroll view around. What if we want to zoom in on what we're looking at and see it larger? Now, one thing when you zoom in, by the way, be careful. That's obviously going to affect your content size. If I zoom in to make what I'm looking at bigger, the content area has to get bigger as well. So sometimes that happens, and then people are expecting their content area to be the same old size, and it's not. Okay, now Scroll View automatically sizes it for you, so you don't have to worry about it, but it's just if you ever look at your content size while you're zoomed in, it's going to be larger or smaller if you zoom out. Okay, and same thing with the content offset, obviously. All right, so how do you make zooming work? Well, you have to do two things. And don't forget these two things. It will not work without these two things. The first one is to set the zoom scale min and max. Okay, so this is just saying how much do you allow to zoom in and how much do you allow to zoom out. By default, these are both 1.0, which means you can't zoom in or zoom out. It has to be the identity size right there. Now, zooming in Scroll View works by modifying the transform, right? We know what the transform is, right? The thing you can rotate, scale, or translate. Well, it's using the scale part of a transform to scale one of its sub-views, we'll talk about which one that is, up and down. Okay, that's how a Scroll View works. That's all it does, by the way. Okay, when you zoom in and out, it's not doing anything else except for transforming the view that you specify. So this tells it how much it can modify that transform. So if it's 1.0, the transform is always the identity matrix, and so it's never going to zoom in or out. So you have to set these, at least one of these two, or you won't be able to zoom. The second thing is to specify that view that gets transformed. Because remember that the Scroll View, that content area is allowed to have multiple subviews. Like we had the logo, we had the aerial view. Okay, so when I pinch, which of those gets zoomed? Okay, so you have to actually implement a delegate method in Scroll View. Yes, that's right. If you want to zoom on a Scroll View, you have to implement this delegate method. And that delegate method is called view for zooming in Scroll View, and it just returns which of the subviews to zoom. Now, to be honest, normally if we had multiple subviews, we'd put them inside of a view, a top-level view, and that's the view we would zoom on. And of course, when we transform that view, all the subviews will get zoomed as well. We wouldn't usually have two different views that are subviews in the content area of a Scroll View, and they're not subviews of some common view, okay? But it's possible to do, but we don't usually do that. Okay, you can also zoom programmatically. In addition to pinching to zoom, you can set the zoom scale and also zoom to a rec. And here's what that looks like. So here I have my zoom scale set to 1.2. That's 20% larger than the identity matrix. Here I've gone back to identity matrix. See how it zoomed out a little? Now I'll go back to 1.2. See, it's 20% larger, right? Even this would not work, by the way, if I don't set my minimum and maximum zoom scale to allow this. Now the rect is even cooler, so if I had this yellow rectangle and I said zoom to rect, it'll zoom the whole thing up so that the rect just barely fits. Or if I had a rect that was much bigger, then it would zoom it down to fit. So zoom to rect is a cool way to zoom in and out. All right, so Scroll View has a lot of delegate methods, like 12 or 15, somewhere in there. I'm not going to talk to you about all of them. You already met one of them. That's view for zooming in Scroll View. But here's another one, just to give you an example. This one's called Scroll View Did End Zooming with View at Scale. And this gets sent to you when the user pinches and then lifts the fingers up. Okay? Now remember, as they're pinching, all that's being changed is the transform of the view for zooming. That's it. Nothing else is happening in there. And when you let go, what if your view, if you are capable of drawing your view much higher resolution when it's zoomed in? For example, let's say your view draws an arc with core graphics. Okay? Draws an arc. You know, an arc is just a bunch of little pixels, right, coming around here. If you zoom way in, it's going to look like little blocks, kind of jaggedy, right? Well, here, when you get this did end zooming at scale, you could set your transform back to the identity matrix, okay, and draw your draw rect bigger so that you're using that arc, and now you get a nice smooth arc. You see how this would work? So this is a good way to draw with higher resolution after you pinch in. You're still going to be doing transform while it's pinching, which is good, high performance and all that, but then when you let go, it redraws kind of sharp. Okay, so I'm going to do a demo here of Scroll View. Hopefully I should have time to show you all this stuff that I just talked about. And then on Wednesday, we will learn about multi-threading. okay, putting things in the background, and will update the app that I'm writing today to do its image loading and all that stuff in the background. Now, I'm going to do that kind of background stuff by doing it over the network, which I was going to show you a little bit of today, but my network doesn't work on my, my new laptop. So I'll just be using local image file today, which is fine. But on Wednesday, I'll get my laptop working and we'll be able to do networking. Because when we load images over the network, they're slow. And you can see it's called Cassini. That's because the images we're going to load up are from the Cassini probe that was sent out to Saturn. And they're big and very, very high resolution. And even on Stanford's fast network, they take a few seconds to load. And that we can't have our UI blocked by that. Wednesday, I'll also talk about text field, and maybe I'll fit in one other little UI element, time permitting. We do have a Friday section this week. It's on this app called Instruments, which is used to analyze the performance of your app, so don't miss that. And then next week, we'll dive into probably table view and collection view, drag and drop, kind of more powerful, more sophisticated things that I haven't been able to teach you yet because you really needed to understand delegation and things like that before we dive into those. All right, let's do Cassini here. Oops, I quit. I didn't want to quit it. Okay, we'll start back. Okay, so we're going to create a new project here for Cassini, and it's going to be a single view app. I'm going to call it Cassini. Not going to do anything special here. We're not going to do, you've all learned about source code control now, but we're not going to do that here. Okay, here's our Cassini. I'm going to do what I usually do here, but take the assets and the app delegate and the launch screen and kind of move them out of the way into supporting files so we don't get confused by seeing them repeatedly. And I'm also going to do something interesting here as well. You know, we get, when we create that single view app, we get this little view controller for free, and this is its controlling view. And a lot of times, or the only thing we've done so far is rename this to be like concentration view controller, or you probably had set view controller in yours as well. But there's another way to do this as well, which is I can just take this and delete it. Okay, so now I have a completely empty storyboard. There's nothing in here. I can delete this too. Let's just delete that, get that out of here, move it to the trash. So now my app is completely empty. The only thing I have is the supporting files here, but there's basically nothing. So there's nothing going on here. So that's perfectly allowed. Now if we do that, how do I build it back up? Well, I'm going to build an app here, Cassini. Initially, it's not going to do anything with Cassini. It's just going to have an image in a scroll view. Okay, it's going to allow you to choose an image and put it in a scroll view. So I want to create my own view controller that shows an image, and I'm going to create a new view controller to do that called image view controller. So I'm going to go here. Yes, it's a view controller. I'm going to call it image view controller because that's what it does. It shows an image. I'm going to create it. I'm going to make sure I put it in the right place here. And here's our image view controller. I'm going to delete all the code out of it just so it's clear what code I'm adding. I'm going to go back to my storyboard, which is completely empty, and drag out a new view controller and go to the identity inspector over here and change it to be an image view controller. Now, I haven't done one thing that's very important that is causing this warning. You see this warning up here? It says image view controller is unreachable. That's because there's no arrow. You see? Remember the arrow that I moved over in Split View Controller demo? There's no arrow. So how do I put the arrow? There's no arrow. Okay, how do I get it? Well, you can do this by inspecting a view controller in the normal inspector. And look at this button right here, is initial view controller. Boom. Okay, now it'll come in and this will be our view controller. Okay, so let's start here by just not having a scroll view and just having an image view. I'm just going to take an image view out of here. Here's one. Okay, I search for the word image. Here's an image view. So image view, like I said, is kind of like UI label, except for it's for images. And I'm going to put it in here, go edge to edge right there. Let's actually see what this looks like on an iPhone 10, because of course we have safe area issues there. Zoom in a little. So I'm going to move size this actually so that it covers the safe areas. See how that's in the safe areas right there? Now, what I want to do, and let's go ahead and while we're here, let's go get our view controller and create an outlet to this image view because we're going to want to talk to this. So I'm just going to control drag into my class and call this image view. So I have an outlet there. Now I want this big image view right here to go all the way to the edges. Okay, I don't really want it to respect the safe area for now. Okay, we're going to have scroll view and it'll help us with that later. But I want it all the way out. It looks cool. I don't mind if a little bit is covered by this and a little bit is covered by that. It's fine by me. I think my image will look cooler to do that. Now, how do I control drag to the edges here? Okay, I can't get to any of the edges, right? Because it's right on the edges, so I can't pick it. Well, we're going to use, again, I'm trying to show you auto layout a little bit at a time, one drip at a time. So we're going to start using these little things in the corner here. You see in the lower right-hand corner. We already know about this one right here, embed in stack view. We're not going to use that. And we actually have seen this one, I think, which just lets you clear all your constraints or reset to the blue line suggested constraints, etc. But we're actually going to use a different one, which is this one right here. It just says add new constraints. Look what happens if I select the image view and click this. It offers to let me set some of its constraints. Now, some of these, like width and height and aspect ratio, we know we can get by control dragging to itself. But look at these ones up here. This is essentially pin to the edges. So these little I-beams, if you turn them on, will add constraints. You see, add 4 constraints, add 3 constraints. It'll add constraints that pin them to what's called the nearest neighbor. You see the nearest neighbor? So it's going to look at that edge and say, what's the nearest neighbor there? Maybe it's the other edge of a nearby view. Maybe it's the edge of your super view. Maybe it's the safe area. Okay, so let's see what happens when we add these 4 constraints to our image view, and we'll find out what the 4 nearest neighbors were to its 4 edges. So here we go, add 4 constraints. Now I'm going to bring up the inspector, go to the size inspector to look at my constraints. Remember, that's how you look at the constraints on a view. When you select a view and go to the size inspector up here, you get to see it. And look, the bottom and top, it thought the nearest neighbor was the super view. Self.view, my view controller's top level view, right? But look, on the sides, it thought it was the safe area. That's because the safe area here on this iPhone 10 goes across here, it doesn't include that thing, so it goes across here, down this edge, and then across here, not including that little thing right there, and back up this edge. That's the safe area. Well, obviously the 2 sides are just as close to the safe area as they are to the edges of the super view. And always, Interface Builder will prefer the safe area over the super view's edges if they're the same. But up here, this is nowhere near the safe area. This is right on the super view's edge, but it's nowhere near the safe area, so that's why it chose super view. You see why it did that? Okay, now I don't want the safe area though here. I always want this at the edges. So how do I fix this to not be doing safe area? I want that to say super view. So how do I do that? Well, I need to edit this constraint. But oh no, how do I pick that constraint? I can't see it. Where is it? Well, I'm going to introduce to you the way we almost always actually access constraints, which is with the document outline. Okay, remember this little button over here? And I said in previous lectures and demos, hey, don't worry about this for now. Well, we're going to start worrying about this, because this is showing me everything that's over here in my view in outline form, including the constraints. Okay, see those constraints right there? They look familiar. And these are the constraints between this view and its super view. So here's the 2 that are hooked to the safe area. Here's the 2 that are hooked directly to the super view. So let's click on one and go to the normal inspector or the size inspector, either one for constraints. And we can edit this stuff. Okay, and we've already seen in previous demos how we edit the constant here or the multiplier or whatever. Now we're going to see how we edit the actual connectivity. So this constraint is from the image view's leading edge, setting that equal to the safe area's leading edge. Okay? Well, I just want this to be the same, but I don't want it to be the safe area's leading edge. I want it to be the super view's. So you can change from safe area to super view just by editing the constraint and changing the item it's connected to. Same thing here. I'm going to change the safe area trailing to be the super view trailing. Okay? Now, if I select this and look in the size inspector, you see that all of my constraints are to the super view. Okay? So now my view is going to fill my entire space, forgetting about any space. I don't care if I have title bar for navigation control or tab bars, it's all going to be filling the entire screen behind those things. Or if this is like a physical thing, just it's not going to be able to draw there. But that's kind of what I want in this case. Well, we're going to see more from this document outlined in a moment here, but this is a great way to access everything in your view. It's very easy to get at stuff. All right, so let's go back to our code over here, and we want to write some code that makes this view controller do what it does. Well, this is a controller of an MVC. What is the model of this MVC? Well, I'm going to make the model of this be an image URL. It's going to be of type, this class in iOS called URL. Okay, a URL just represents a URL. It could be a local file URL, or it could be an internet URL. And this is my model. Okay? And so it's my job to take that model, turn it into an image, and present it in my view, which my view right now is just this image view right here. So I'm going to do that right away by saying that if someone sets my model right here, I'm going to set my image view's image to nil, okay, because I'm changing it to a new thing, and then I'm going to go fetch that image. Now the reason I'm making this another little function here, some private func fetch image, is because this thing might be over the network. And eventually on Wednesday, we're going to make fetch image work in a background task, obviously, because it could get blocked by the network. So I'm kind of thinking ahead a little bit and putting this in a separate function as opposed to just dropping it right in here. Okay, so someone set a new image URL, would clear out whatever image we have, if any. Image is just a var in our image view that sets the image. And then we're going to go fetch a new image over here. Now, one thing, since we just learned about view controller lifecycle, I told you that you don't really want to do something like this fetch image unless you have to. So I'm going to do something here, which is I'm only going to fetch this image if someone sets my model and I'm on screen. Okay? If someone sets my model and I'm off screen, I am not going to go fetch that image yet. I'm going to wait until I know I'm on screen. Now, how can you tell if you're on screen? How do you know if your MVC is on screen? Well, here's a cool way to do it. I'm just going to check to see if my view has a window that's not nil. Okay, so we didn't really talk about window, and I kind of told you to ignore it at the beginning of class, and you mostly can, except for that a view, if it's on screen, will have a window var, which is the window that it's in, which is usually just this one window. So this is a kind of a cool, simple little way to check, am I on screen? And if I am on screen, then I'm going to go ahead and fetch this image. But what if I'm not on screen? Eventually I need to fetch the image. So when's a good time to do that? Anyone have an idea on that? Yeah, view did appear, exactly. Let's do it. View did appear. Okay, super.view did appear. At this point, I know that I'm on screen. So now, inside of my view didn't appear, I can just check to see if my image view's image is still nil, then let's fetch it. See how I use the view controller lifecycle there to keep myself from doing any unnecessary work? Now, of course, if my fetch image truly does work in the background, I have more work to do here, which is I've got to give some indication to the user I'm working on it. Okay, because otherwise they're going to say, where's my image? Okay, went to this view control. I don't see any image up here. So I have to give some feedback. But since right now it's going to block the user interface until it gets the image, because we're not doing the multi-threading, we'll just leave it like it is. But you're going to see it when we do it. We're going to put something in there to do that. All right, so fetch image. How do we implement fetch image right here? Well, this is actually pretty easy. We're just going to see if our URL, our model here, is non-nil. Because if it's nil, we don't have to do anything. Okay, because it's whenever someone sets a new image, we set it to nil, and whether we fetch it here or here, if that image URL is nil, we leave it blank. Okay, nothing in our image view. But if I have it, then I need to go out on the internet and get the data at that URL and turn it into an image. Okay, so how do we go out on the internet and get data from URL? We do that with the data object. Remember the data object I talked about? It's just this bag of bits thing. Well, it has an initializer, which is give me a URL and I'll go get the bag of bits from that URL. So we can set a little local variable, which I'm going to call my URL contents, equal to data. Now let's look at the various initializers for a data, and it has a lot of them because it's a bag of bits, so it can convert to a lot of different data types, right? Bags of bytes and all kinds of things here. But one of them is this one right here, contents of URL. What's that word after content of URL? Throws. Okay? So why can this throw? Well, it's going out on the network maybe. Lots of reasons it can throw. Network connection's bad, the server rejected the request. There's probably 20 different things it could throw here. Okay? Now, it turns out we don't care about any of them. Okay? If we did, let's go ahead and put contents of URL in here, and the URL is URL. If we did, since this throws, what do we have to say in front of it? Try, yeah, we have to try it because it might fail. And we could wrap a little do catch let error here and do this thing, catch the error, and then process the error. Oh, it was a server timeout, network unavailable, all these things. But we don't really care about any of that stuff. We're just a lowly image view controller. We just want to put our image view up or not. So we don't care about the error, so we're not going to do it with a do catch thing here. Instead, we're going to use this. Okay, right now, this URL contents right here would be a type data. But I'm going to change this to try question mark, which says try this thing, and if it fails, just return nil. So that makes this now be of type data question mark, right? Optional data, because the try might fail. Okay, so I've got this content right here. Now I'm just going to say if I can let my image data that I got from that URL equal the URL contents, then I can create my image from that data. So that image data is probably JPEG data or something like that. So I'm going to say here that my image views image equals UI image. Now UI image, we've seen UI image named, right? That's the one we've used. There's another UI image one called UI image with data, and you give it image data, which is a data object, and it will look in there, that bag of bits, and see if it recognizes anything that looks like an image, like a JPEG file or something like that. So that's kind of cool. All right, so that's it. That's all we need to do to show an image here. I'm going to do one other thing, just for demo purposes here, which is in my view did load, always do super here, I'm going to say if by the time I load, my image URL is nil, then let's load up kind of a sample image. And I have a sample image here in a file, a URL for sample image. Let's go here. I'm going to drag this in. Demo URLs right here. Again, let me show you this demo URL, what this looks like. So the demo URLs that I have this Stanford one right here, okay, which is a big picture of the oval. And then I have these NASA ones right here for Wednesday's demo. Now again, I don't have any network, so I can't actually do this one over the network, so I'm going to do a local one, this using this bundle main URL. So this gives me a local one, so I have a local version of the oval here. I'll just drag it in, copy that in, and just show you what this looks like over here. Right, so it's just a big thing of the oval there, very high resolution. Notice I click this button over here, Target Membership, to make sure that this oval, when I install my app on the device, gets included, okay, because I'm looking at it locally. But I'm just going to get a URL to it. It just happens to be a URL to a local file as opposed to a URL for the network, which doesn't matter because we're not doing multi-threading yet, so it's perfectly fine. Okay, so that here, I'm just going to set my model equal to my demo URLs.Stanford. Okay, so that's just that URL for the local guy. All right, so let's run and see what this does for us. Actually, we're gonna rerun this and do it with iPhone 10, but here it is, okay? Now, it's showing the image, but that really long image got smashed, okay? And if I go this way, it's doing a good job of sticking to the edges, but of course, it's kind of smashed This is not Stanford in all its glory here, so we need to fix that. And how do we fix that? Of course, with scroll view, right? If we put a scroll view in there, it can be its normal size, and we can scroll around on it, zoom in and out, and look at it. So that's perfect opportunity here to fix our little app with scroll view. Now, I'm going to show you both ways to do scroll view. Scroll view done from a storyboard and scroll view done in code, so that you both see how to do it in the storyboard, because it can be a little bit tricky there, and so you can see what's going on with the content size and all that stuff in the code. All right, so let's go to our storyboard right here, and here's our image view. Now I'm going to add this scroll view. Again, I could go over here, and if you go down here and search for scroll view, you'll see you can drag out a scroll view and then just drag subviews into it. By the way, when you are interacting with the subviews of scroll view in Interface Builder, it's talking about the content area. Okay? So Interface Builder doesn't even know anything about scroll views, subviews, except for that they're in the content area. So for example, we're going to create some constraints here between the image view and the scroll view. That's going to be constraints between the image view and the content area, that big white area of the scroll view. So that's important to understand when you're working in Interface Builder. But I'm not going to do it by dragging it out down here. Instead, I'm going to use that embed thing, right? So I have my image view selected here. I'm going to go embed in scroll view. And it does it. Now, like I said, it puts this little 20 pixel border around it, which I don't really want. So I'm going to resize this to be perfectly hooked up to my edges right here. Notice that now the image view has still got the 20 pixels, so I'm going to move it. So I've kind of put these two things where I want. Now, it really doesn't matter actually where I put the image view in terms of its size and angle. What's important here is that that image view be tied to the edges of the content area. And why is that important? Not so that the image view is the right size, but so that the content area is the right size. If I tie the image view's edges to the content area and the image view changes size, the content area will change size. Okay? And I have to have that content area always matching the size of the image view if I want to be able to scroll over the entire image, right? So when you do this in Interface Builder, as opposed to in code, you do this with constraints by hooking the image view to be tied to the scroll view, which in fact it already is, because when I did embed in scroll view, the image view was already tied to its super view, so it kept it. It's just that it got these little extra 20 points in there, which I don't like. Now, the thing here is the scroll view itself is not tied to its edges. I resized it, but there's no constraints. So I'm going to tie it to the edges in the same way that I did the other one. How do I choose the scroll view though? Okay, when I click here, dang, I keep getting the image view. Can anyone think of a way we could choose this? The document outline, absolutely. Let's go over here to document outline, all right? And here's the scroll view right here. I just selected it. Okay, so it's really easy in the document outline to pick what you actually want. Okay, so I can pick my scroll view here. And once I have my scroll view here, I can go down here to this thing we had with the edges and just hook its edges up to its nearest neighbors. Okay, same exact thing we did with the image view. It does it here. It had the same problem where it put the trailing and leading to the safe area. Now in the document outline, when you're looking for constraints, be careful about the indentation. These constraints go to the image view. These constraints go to the scroll view. You see how the indentation matters there? So here I'm going to change the safe area of this to be super view also. Super view. Okay, we got that. And then the last thing I want to do here is fix all this all these 20 points thing that it gave me when I embedded, because I don't want that. I can edit that right in here, right in my size inspector here. So I'm just going to say edit, make that 0, edit this, make that 0, edit this, make that 0, edit this, make that 0. Okay, so now I've got good looking constraints right here. See, the scroll view is hooked up to its super view. You can see that the image view is hooked up to its super view, which in Interface Builder means the content area of the scroll view. I can't emphasize that enough. Okay, when you have a view that's a sub view, see how the image view is a sub view of the scroll view? It's indented right there. That means the image view, when the scroll view is your super view, you're talking about the content area. Now, why is this still red? Okay, it seems to me like I've specified all my constraints between these views. Why is this red? Well, let's go look up here and see what it says. It says scrollable content size is ambiguous for scroll view. So it's talking about that content area. It's saying, how big is that thing? Well, the answer is, it's as big as the image view because the edges of those two things are tied together. But Interface Builder does not know how big the image view is. Why? Because it has no image. Okay, this image view is empty. It has no image. So Interface Builder is like, I don't know how big that thing is. So I don't know how big the scrollable content area is for the scroll view. Now, this is an unsolvable problem because we don't set the image until our code runs. So how do we deal with this in Interface Builder? Well, Interface Builder has a really cool little feature. If you inspect the image view right here and go down to the bottom, you see this thing, intrinsic size? The intrinsic size of something is the size that it wants to be to fit its content. So for a label, an intrinsic size of a label is however small it can be and still fit all the text in there. For an image view, the intrinsic size is however it can be with the natural aspect ratio and size of the image. So that's its intrinsic size. Well, its intrinsic size, it's right now set to be the default, but you can actually set it to be a placeholder. This placeholder, which I'm going to set, is just any random size you want, and it'll only use this in Interface Builder. It's just holding this place in Interface Builder, right? In code, we're going to set it. So look, that got rid of my red complaint, because now the image view has a size, and so the content area is going to be 375 by 812, but only in Interface Builder. Once it runs, it's going to be whatever the size the image view is, which is going to depend on what image we set. Everybody got all that? Okay, so this is kind of you can see what I was saying about it. It's a little bit tricky with the scroll view. It takes a little bit getting used to understand that when you are setting constraints between the image view and the scroll view, you're talking about the content area, and that's controlling the size of the content area. So let's run, that's all we have to do. We don't have to do anything in the code here because we've set all these constraints. So let's go ahead and run this thing. Keep forgetting to do this on iPhone 10, which is a little more interesting. In fact, let's do it on iPhone 10. Let's stop here. iPhone 10. iPhone 10 is a little more interesting because it has that safe area built into it, whereas the other one doesn't. Okay, so look, here's our image. You see how this blue sky of our image is up here where the time is and all that. And if I scroll, woohoo, it's showing, okay, our tree up here. That's cool. It can scroll around. Notice that if I scroll down, it'll reveal the safe area, right? It'll make this be lower than the safe area. So that's the scroll view being smart about the safe area. Even though we tied it to its super view's edges, it still knows there's a safe area, and it goes all the way down, and the same would be true down at the other side. So here we're scrolling through. We can go landscape, for example, and just scroll around. Okay, find the stuff we want. Oh, there's the dish right there. And so that's it. That's all that's required for scroll view. Works super easy. Now, what about doing this in code? So in code, in some ways, it's almost a little easier than doing it because you don't have the 20 pixel thing and all that stuff. So I'm going to do the exact same thing here in code. So I'm going to take my image view and delete it. So I just deleted my image view. I'm going to leave my scroll view in there, though, okay, because I need to talk to the scroll view to set its content size. So I'm going to leave that in there. Let's go over here and get our code up at the same time. I'm going to create an outlet to this scroll view right here so that I can, again, talk to it. I don't need my image view outlet anymore because I'm going to create it in code. In fact, let's just create it right here. I'm going to say my image view equals a new image view. I'm just going to create the image view. It's of 0 size, but that's okay. Whenever I set an image, I'll resize it. And then let's control drag to hook up to our scroll view. Call this scroll view. Now we have a connection to both. Here, we just want the image view to be in the content area of the scroll view. So as soon as the scroll view gets hooked up by Interface Builder, I'm going to ask the scroll view to add as a subview my image view. Okay, so it added it. That's nice. Again, the content area is size 0, and so is my image view at this point, so it's going to be completely blank. Anytime I set the image, like I do it here, and actually I do it up here as well, I need to tell the image view to size itself to fit. So size to fit means make yourself your intrinsic size, right? The size that will fit this image the best. And now the image view's frame has been set, but if I don't do this, scroll view.content size equals equals the image views frame dot size. If I don't do that, then it's not going to scroll at all. Do you see why? Okay, otherwise the content area would be 0, 0 size. I got this big image, and I'm trying to scroll in this 0, 0 size rect. It does nothing. Okay, now I actually have to do the same thing up here when I set the image up here back to nil. I want to resize my content size back down to 0. Now normally I would say, oh, copy and pasting code like that, that's bad, don't do it, but this is a demo, I don't have time to fix it, but actually I'm going to take the time to fix it because I'm going to fix it in a way which I think will be kind of interesting, which is I'm going to make a var, actually a private var, called image, which is going to be of type UI image. And it's going to be computed. Every time I want to set my image or get my image, I'm just going to get it from the image view. So I'm going to say get, return the image view's image, and set is going to set the image view's image to the new value. Okay, so this is just a normal computed property right here. But the cool thing is now I can put this in here, so that every time I set my image, I resize my image view and my scroll view. And so up here, I can just say image equals nil. And down here, I can just say image equals the new image. And I don't have to have this code copied in 2 different places. So here's an example where you can use a computed var because conceptually this is my image. It happens to be stored in the image view. I don't need to duplicate it from there. I'm just going to return it and set it in there. But I can also do my nice little setting on the side there. Okay, that's it. So it's easy in code as well. Okay, this is a big file, so even locally it takes a while to load, but here it is. Okay, so we got the exact same thing we had before. We can still find the dish in here. We can rotate. Okay, but it would be really cool if we could see the whole picture. Okay, it's a little bit annoying. We can see just 2 little parts of it. It's kind of cool actually, to be able to look at parts of it, but we'd like to be able to zoom out and see the whole thing. So now we need zooming. So what are the 2 things we need to do zooming? Set the minimum maximum zoom scale. Provide a delegate that says which view to zoom. Now it's obvious which view we want the transform to work on here. It's our image view. So let's go do that. And I'm just going to do that. I'll set those things right here. Okay, here's where my scroll view is set by iOS. So let's have the scroll view's minimum zoom scale. We'll go 1/25. Okay, 1/25. So we'll allow to zoom out so that the image is 1/25 its normal size. And then maybe for the maximum zoom scale, I'll say 1.0. Why would I say 1.0? Well, maybe because I don't want you to zoom in so that the bits look kind of, pixelated. So I'm not going to let you zoom in any more than 1.0. So you can zoom into 1.0, no closer, and we'll let you zoom all the way out to 1/25. So that's part 1. Part 2 is scroll view.delegate equals what? Self, yeah. I'm going to be the scroll view's delegate, okay? Now, this is going to generate an error right here because self is not a UI scroll view delegate. That's easily fixed. We go up here and say, yes, I'm a UI scroll view delegate. Thank you very much. And since all those methods are optional Objective-C methods, all my errors go away, okay? However, scrolling not going to work unless I implement that view for scrolling method. So let's do that. It's called view for scrolling. There it is, view for zooming, I mean. And we just need to return our image view because that is the view, the subview in the content area that we want to be transformed when we pinch. All right, so let's try it. Okay, here we go. We can still pan around, but now we can zoom. Everyone remember how to pinch? Hold down the Option key right here. Oh, got a low battery. Hold down the Option right here and pinch, and we can zoom out here. Okay, all the way out to here. Maybe look better if we do this. There we go. Like that. Okay, zooming, real easy. Okay, so hopefully that gives you the full tour of scroll view in terms of adding subviews, managing its content size, doing zooming, all this stuff. Very straightforward, easy to use. Next time what we're going to do is the images that we're going to get are going to be these huge images over the network. Hopefully, if I can get my Mac to work on the network, and that's going to be slow. And we are not going to want our UI to be blocked waiting for that to happen. We want it still to be highly interactive, and so to do that, we need to do multi-threading. So that'll be our primary topic at the start of Wednesday's lecture, and I will see you all then.
For more, please visit us at stanford.edu.